So for those of you who may not know kind of who we are, I work at Hasura, and we are kind of instant GraphQL for your data. So that could mean data in a database. That could mean data in a REST API or microservices. But the general idea is that you have some data source that is not currently exposed over GraphQL, and you'd like to expose that data, and you need a way to do that. That also helps provide a framework for things like Auth and caching, RBAC, stuff like that. So we have this open source product, and you can spin it up against your database instances and pull in external REST and GraphQL APIs that have business logic or might be provided to you by vendors. And it kind of gives you this unified data graph, and it really makes it easy to access your data kind of no matter where it's stored. So let me see if I have a chat here, pop it open. Will this be available on YouTube after? Yeah, absolutely. That is the plan, at least as far as I'm aware. But yeah, so that's kind of the general idea with Hasura. The talk today, the idea was to sort of showcase the ways in which you might be able to use Strapi, particularly for its content management and like CMS-like abilities, in conjunction with Hasura. Because they both provide really valuable things, and there are things that one can do that the other might not be so good at, and we just kind of wanted to demo in a real world scenario what that sort of usage might look like, and the idea being you have a takeaway and you walk away feeling like, hey, I learned something, and this is applicable and practical. So yeah, it's always a little bit difficult to do these conversations when you don't have an idea of what everybody's background context is. But at a high level, what we're going to do is we're going to take a kind of ground up Strapi app, and we're going to do a combination of modeling some data here in Strapi and really leveraging its ability to have these heavily content-focused CMS type-based fields, along with some of the things that Hasura provides, which is the ability to join data across data sources and also pull in endpoints and handlers from like REST and GraphQL APIs. And we'll kind of show you one approach that you could take. I kind of want to preface this by saying that this isn't the I think now it's been available. Oh, I think Harsh's message got sent to all panelists. Yeah, if you've registered, we'll send you a recording afterwards. Yeah, so the idea kind of being that we're going to have one Strapi instance, one Hasura instance. For this particular approach, what we're going to do is we're going to have them connected to the same database, though you wouldn't necessarily have to do that. They could be connected to entirely different databases, and we'll talk about that a little bit more. But yeah, they're both fairly flexible. We'll just kind of show one way of working with it. And so to kind of set the stage here, one thing that I've done is I've just created this sample table, just called like something from Strapi. It's inflected it to be plural. And all that that has is a date field, and it has a rich text field. So if we edit this, we can see that they're quite literally called rich text and date field. And we have some content in here. And the way that this is going to interact with Hasura, and I'll kind of give more context on the Hasura backend in a second, is that Hasura is sort of able to see the same data because with this particular setup, they're both connected to the same database, which is a Postgres instance. So what you can see is that we have this database record that's visible on both databases. And if we edit it here in Hasura, let's just make this something else that isn't this. So not very rich anymore. If we save that and then we go back to browsing rows, you should see that that has updated here. And then also if we reload the instance here and then edit it, you can see that they're synced. So the way that this is working is basically Hasura allows you to connect the database. So you can just click here and put in some info. And they're both connected to the same Postgres. There is one kind of contingency about working with data in this way, is that you would typically choose either to connect to the data via GraphQL, right? So they're sharing data with a bridge database, but the other way that this could be done is if we had pulled Strapi's data in as a remote schema, which is like schema stitching. Both approaches are viable. It's just really dependent on how you want to architect things and whether or not you're using the same database. So I thought that something that would be kind of a useful demonstration would be to walk through what it looks like building some basic tables and records here, maybe joining them with data from an external source, and then showing what it looks like to pull that data into something like a React app through GraphQL. So one of the things that Hasura allows you to do is these things called actions and remote schemas. And they're sort of ways to pull in external APIs. The important bit, though, is that you can join data with them. So if you were to have an external schema and add it as a data source, you could then say, the field that comes back in this data is actually attached to data in my database. And so essentially what we can do is say that something from Strapi's, the ID here, maps to a GraphQL instance and the data that comes back from that endpoint. So one thing that we can do is kind of spin up like a glitch instance. And we'll take this record and we'll take the ID here. And we'll just fake a resolver that doesn't necessarily like have any actual context. But it's just going to return static info. So for this example, we only have one ID. So what we would do is we would make this hello. We would make this return like, I have to fork this really quick. So if we have some type that isn't this, so if we have like type, my type, and it has rich text ID that's of type int, and then hello is going to return my type. Then what we can do is have this just return an object of rich text ID, and it'll always return 1. And so if we save this and we preview it next to the code, then now we have this here. And if we write a query, then hello. Run this, get rid of the schema. So now we have a GraphQL resolver, and all it does is just return this rich text ID. That's always one. It's not very useful, but for demo's sake, it's fine. And basically what we can do is we can take this GraphQL URL for the Apollo server that we just created. And we can come in Hasura and say, hey, we have this remote GraphQL schema. And this is like not very useful because it's not a very useful schema, but this is where it lives. And we'll just forward headers and we'll click add remote schema. And so what that's done is it's taken all of the information that's available in this remote schema. So all of the types and resolvers that you can query here in the playground, and it's combined them with all of Hasura's GraphQL types and resolvers, which we briefly skipped over, but the kind of fundamental point of Hasura, if you really boil it down, is that if you have data, like we have this something from Strapi's table connected, then you get this generated GraphQL API, as well as real-time subscriptions. You can do CRUD on it. Where it gets interesting, though, is when you bring in data either from other databases or from other APIs, like the one we just connected. You can see that we have hello now, and we're able to query that from our Hasura to the other instance. So if we run this query from Hasura, then what it's going to do is it's going to delegate and kind of just proxy that request to the remote resolver and then return the result, which again, this is not useful at all, super boring. But where it does get useful is when you do things like come into your data and on this table, right? So we have something from Strapi's with ID 1. We can make a relationship from our data to data sources that we don't necessarily own, right? Or that live outside of this instance. And so what we can do is we can say that the not very useful remote schema hello query, the rich text ID, which I would have to modify this really quickly to take an argument so that it can read it out of the query, but you get the point. We can say that this rich text ID actually maps to the ID in the something from Strapi's row. And then what you'd be able to do is query data inside your database, and it would actually feed the database rows into these remote schema relationships, and it could go fetch data from other systems or other databases and join the result for you. So let me just modify this really quickly so that it takes an argument. So we'll make this take ID that's an int and returns my type. And then we save it. We check the schema. Hello takes ID. And then what I have to do is come in here and in metadata, I just got to reload this, basically telling Hasura, hey, one of the things that we connected, these external systems, the schema has changed. And then now if I come back in here, I go inside the relationships. I say I want to make a relationship to some external system. And there we go. So we can say this is like remote schema relationship from column. I gotta move this. ID. So now we can feed the column of the database row into the GraphQL query and say pass the underlying records ID into the GraphQL argument ID. And that's how the relationship works. And so if I save this, okay, so now we have a remote relationship from the table something from Strapi's to not very useful schema .hello resolver, which means that if I query this and I come back in here and I ask for something by Strapi's and I want the ID, the rich text field, I can also ask for the remote relationship and the rich text ID. And now you'll see that it has just fetched this remote data joined with the records ID. And that's not very impressive because it's static. It always returns 1. But as a proof of concept, I could make this say like return the ID times 7 or something, and you get the point. The number here is dynamic, right? And so basically this forms the basis for how you can integrate really useful systems like Strapi into Hasura. Because when you look at Hasura, this isn't necessarily an interface that you would want to give to a non-technical person on your team, right? It's just not great, and it's just kind of meant for a very bare view of the data and basic editing capabilities. But with Strapi, what you can do is you can have these data types, and they call them, collections and content that is a lot more centered on the user experience of editing and viewing this inside the dashboard. And then so you can have non-technical users, or even just yourself if you want a good experience, coming in here, entering this sort of CMS-based data, but then being able to join it with external systems really easily. So I think a good example of that would be one thing. So we can create a new collection type. Let's go users, content types builder, create a new collection type, say new Strapi type. So we'll do JSON, so post JSON field. We don't have very good editors for that. Media, single media. We'll skip relation. But yeah, that should be the email validation is probably better too than what you get there. So we'll finish. We'll save that. And then now we have this. If we come back into Hasura, you can see that there's these untracked tables and types, and we just want to tell it, hey, watch this table and expose it over GraphQL. And so now we have these fields here, and if we were to come back here, we can now query and do mutations and subscriptions on all these types as well. But that's not going to be a very solid authoring experience from Hasura because these are complex field types. And so if we come here, we were to add something new here, then we get a nice JSON editor, a media field, So yeah, the email's not valid. And we could select an asset to upload it there. One of the things that you have to work around when you do this, I don't know if I made this nullable, so I'm not sure that I can save it. Okay, sweet, it works. One of the things that you have to work around with this is that the user auth system and roles, it's kind of the one or the other scenario. So Hasura has this notion of permissions, and the way that Hasura does it is basically that you create arbitrary roles and you put checks, which is basically that, like, if the user's ID is equal to the currently logged in user's ID, then allow them to access blah blah blah. The one trade-off of doing it like this versus doing it with a GraphQL-based approach is that you may not be able to leverage both auth systems, simply because they're both going to be reading and writing from the same data source. And you're going to have to pick kind of one of them to be the entry point, because otherwise you need to implement auths and roles in both of them. The other thing that you have to be aware of, and this is more of just like a generally Hasura thing, but from a naming conventions point of view, there are a small subset of the tables that Hasura can't track and interop with GraphQL, which is also part of the barrier there. So for example, we can't use the roles and permissions table because of the dashes in the naming convention. So yeah, that's essentially the only thing to be aware of there. So that basically covers the rough outline of how to work with content between the two systems if you use the database as the connecting data source. If we were going to use authorization, an implementation of that would basically look like this. So it would be something like a users table. We'll put an ID and created at in there. We'll put an email that's text and unique, and then password that's text. So you add a table. Yeah, just fetch metadata, that's fine. Okay, and then we track it. And then what we would do is say that on the permissions, a user is only allowed to select rows if the ID of the user record is equal to this X Hasura user ID. And essentially what this is Hasura has a claim system. So you sign these claims inside of your token when people log in, and you can use these claims in your auth check. And so a common idiom is to put things like a user ID or an organization ID or a tenant ID so that you can reuse those in your permissions check. And so we'll put access to all columns except for their password. Aggregation, we haven't talked about this, but Hasura has like standard deviation, min, median, max, etc., that are useful in some cases, but they don't need permissions to that. So now what happens is that you can see that we can see all of these tables and queries and stuff over here. And the reason for that is because, let me uncheck this because this doesn't make any sense. This is a leftover. The reason is because we have this admin secret enabled, which is like your super user password. But if we uncheck that, then now we can't do anything. Basically, we have no permissions, we've just become an anonymous user, and we haven't set permissions for anonymous users. If you want to see what that looks like, if we just quickly throw, for example, in here, if we set anonymous and we say that anonymous can select something table without any checks, and they can just view everything. Then when we come back here, now all of a sudden, because we're an anonymous role, we can see this. But let's really quickly throw some data inside of users, just so there's something. So this will be user1 at site.com, and password is very secure. And this will be user2 at site.com and very secure too. Okay, sweet. So now we have 2 users. And what we want to check is that when these users are logged in, that they can't see anybody else but themselves. And so you can quickly emulate this in the Hasura console, because this would be a really pain to have to do the full auth flow. And the way that you emulate it is you have to verify that you're an admin. And so if you put an admin secret, then now you can kind of do anything. And if you're an admin secret, you can manually set these token claims as a header. And so then what we'll do is we need to set a role, which we can do with Hasura role, and we'll set a role as user. And then as soon as we do that, the only thing that we can see is this hello remote schema and the user records. Now, if we query user though, and we haven't set this Hasura user ID, I haven't checked this box yet, we should get nothing back. So let's do an ID and an email. There should be, yeah, so it'll say you're missing your Hasura user ID. Nope, you can't have anything. And so let's impersonate, and let's say that we are user ID 1. And then now if we query, we can see user ID 1. Even though our query was technically for every user in the whole database, our permission system says that it's going to scope it to only records where the user ID is equal to this value. And then again for user ID 2. And bam, now we are user ID 2. If we take off the Hasura role and the Hasura ID, and now we're just back to admin, or if I just set Hasura role to admin with the admin secret on, then when we run this, we'll be able to get every user in the database. But at a high level, that is how Hasura's permission system works. And the authentication system is maybe a topic for another day, but it's super flexible. Basically, Hasura just wants you to give it a signed JWT token or a webhook response, and it doesn't care how you do it, as long as it has certain claims in it. Okay, so how is this useful? So in a real app, you're probably going to have a combination of like user roles, right? You're going to have access control, and you're going to need to fetch that data. And so what we want to do is probably attach some of this data that we have from Strapi to a user, and then do just a super quick demo of you know, what does like a React and like Apollo front-end app look like using this integration, these two platforms. And so one way that we can do this fairly easily is on the user side. If we modify it and we say that a user has one of these something from Strapi records, so we'll just attach one of those. So we'll just say something from Strapi's ID, and that's going to be a column type integer. And we just need to put a foreign key, and we need to tell the database that, hey, this something from Strapi's ID is bound to, I need to save that really quickly. Something from Strapi's ID on the user connects to the reference table, something from Strapi's ID. So if we save that, now we've just created a foreign key in the database from Hasura to Strapi. I mean, not really from Hasura to Strapi, it's all just Postgres, but you get the point. And so now what we do is we have to come in relationships, and Hasura will be like, hey, you have this foreign key, and I know about these tables. I know these things. So helpful, I'm gonna suggest you probably have an object relationship, and this is what you want. And this relationship is how you expose things over the GraphQL API. So typically all you have to do is just accept this and accept the default name. It's smart enough to just inflect the right naming convention for you unless you want to customize it. And so we've added one side of the association now. So now we can query from the user to the something. But if we want to be able to go backwards, we need to do the inverse, which will be the many to one. And so you come in here inside of the somethings, and it knows to suggest the inverse relationship, which is the array or the many to one. And you just click OK. You click save, and sweet. And right now we can now query the GraphQL API and join these two together in one query. But that won't make a lot of sense until I manually insert one into the user. So let's just put the very first one that we created on this user one, and we save it. And now if we browse rows, this is the short way to do it, we can view relationships inline. So now we can see that user one with a very secure password, that user has a relationship to this something from Strapi, very rich text field item. Okay, sweet. So that's basically all there is to know about that. The only thing extra to say about that is you can also make relationships to things that you can't do in SQL. You can make relationships to things like views, which aren't possible otherwise. And you can use that to do some pretty cool stuff. But that's the gist of working with relationships in Hasura. And so now, if we query from the user and we come in here, now we can see that we have something from Strapi that we can query, and we can query all this information. So let's get the ID, let's get the rich text field, and then even cooler, we can say, hey, reach out to that remote relationship on the remote schema that we stitched, and hit that Apollo server and give me back the rich text ID that's related to this record. So we're going from Hasura here to something we made in Strapi, to an Apollo server that we stood up in 30 seconds on Glitch. And we're just going to query this all in one query. And ta-da, there we have it. So yeah, super, super cool. And then if we just switch our roles from not being an admin to actually being a user, then, oh yeah, we don't have permissions to view this field. So we gotta change that really quick. Something from Strapi's permissions on user can select. So a user should be allowed to view something from Strapi's if inside the user's array that it has relationships to, the ID is, there's one user whose ID is equal to the current user ID. And so, yeah, fetch metadata. I don't know why it's doing that. but I'm just going to spam updating the permissions again. Sweet. And so, yeah, this is kind of cool. You can also, there's a bunch of stuff with permissions, but what we're saying is use the GraphQL relationships that we just created from users to basically check the entire list of users that is connected to any record in this something from Strapi's. And if that user's ID is equal to the current logged in user's ID, then they should be allowed to read this particular record. And there's things like exists for doing like cross schema and cross table joins and or Boolean checks and like column value comparison operators that can select across tables. You can get pretty wild with it. But okay, so now if we go back here, we can see this now, which is great. And let's just grab this and the date field and the remote relationship. And does that work? It does. But because we're user 2, that relationship doesn't exist. This resolver always returns 1. So the remote rel won't return. So yeah, that is an overview of how to do like complex multi-system data joining and permissioning. And then the last thing, I wouldn't say last, but kind of like to put it into practice, the thing that we would need to do is actually integrate this into a front end. And this is the part, I don't know if that excites you guys, but this is the part that I'm really stoked about, because there's some tooling that you can use. Not for Hasura, but just for GraphQL APIs in general, that make it an incredibly easy and type-safe dev experience where you can basically just not do any work and auto-generate a fully type-safe client SDK. And it's not like GraphQL code gen where you have to write all the queries like this, and then it spits out one usable query per manual query. It allows you to just pass arbitrary queries, and it does dynamic type detection based on the arguments in the object. So it's like a meta type system. That probably doesn't make a lot of sense, but it'll make more sense if I show you. And so let me open up a code sandbox and basically show you what I mean. So I'm just going to show a general example, and then we can look at integrating this with that actual URL. I can change the links here. But the idea is there's a couple tools that you can use for this. One is called GraphQL Zeus, and it's written by the folks who write the GraphQL IDE editor online that you might have seen. And this one is solid. The other one is called GenQL. And they are both essentially exactly the same library with some minor API differences. So pick your poison. But okay, so let me show you why this is so cool. So basically what this is, let me see if this project is still up or if it's been deleted. It's been deleted, but I can change the URL so it works with this one. So basically the way that it works is I assume that some of you are familiar with things like Apollo's React query hooks for things like use subscription, use mutation, use query. These libraries allow you to kind of write wrappers so that what you wind up with is basically like a magic SDK. and it's entirely auto-generated from your GraphQL server, meaning if you make a change to your database in your GraphQL schema, it's not a big deal. You just rerun the generator and it all comes out. So what these like use typed hooks do, if I undo this, you can see that in the query, the return type is this data object that's a maybe. And it contains this array of user objects that have an ID of number and email of string. Now, if I remove ID or email from the selection set, so if I say, no, I don't want email anymore, and then I hover over the return type, now you can see that it's user ID and number. And so then if I do query dot data dot user dot 0 with index dot ID, then that value is there and it tells me that the ID is a number. And this user and ID are coming directly from my database. So this was actually a Hasura instance. And so what I can do here is I can hit autocomplete and I can see the list of every single property inside of my GraphQL API that I can query. And so if I select email and I hit autocomplete again, and I say to-dos, and I select user to-dos, and then I press autocomplete, then it shows me strongly typed definitions of all of the possible filter clauses. So I can say where, and then these are all to-do properties. So this is like all just dynamically calculated at runtime. And then in the selection set, can do the same thing. I want to grab ID true and is completed true. And then you'll see all of this propagated inside of the response without ever having to write a single manual type. So now if we check the response type, look at this. And this, yeah, I mean, this just was completely life-changing for me as somebody who works in the GraphQL ecosystem and frequently is, building on, tooling and, SaaS applications. But yeah, super life-changing. Okay, so this is what we can do. I'm pretty sure that I can change the, I can just try to generate it here and show you how you can use something like this. So basically what you would do is they have these generator commands, which, so here we're gonna hit the GraphQL endpoint, spit it out into src/utils/generated, and then we're just going to pass the header with our admin secret. And so if I run this, okay, then now that you can see there's this generated GraphQL client SDK. And this auto-generated SDK is going to be TypeScript types for every database type and every GraphQL operation, argument, input type, and return type that we can also use dynamically calculated. So basically, here's all our database types. I don't know if you can see that. I'll zoom in. But yeah, so now we kind of have this strongly typed auto-generated GraphQL SDK, and it's fully dynamic. And then the way that you can use this, because it's agnostic, is by making these query hooks. And so essentially what you can do is take something like an Apollo client, or whatever it is that you like to use. Could be like SWR, stale well revalidate, whatever it is. But the idea is that you can basically just use generics and generic type programming to make these automagical type inference versions of whatever the API is, which is super stellar. So if you see it pulling in this generated GraphQL client SDK here. And so just to test this, if I were to do something like, use query, and then I autocomplete it, oh, it's use typed query. Whoops. Then now you can see that these query operations, the user something from Strapi's, new Strapi types, hello, these are all of the operations in our GraphQL instance. So if I get rid of the role, then here are all of our possible query types. And let me move this chat. We look at the query root, then here they all are. And so now we've just generated this Apollo compatible type wrapped versions of all of the query and mutation and subscription hooks that every developer on our team now no longer has to say, who made what change? What does the schema look like? Is this the right args? Because we just say like, hello, and okay, it takes an ID that's a number. Okay, we'll put in 1. And then what does it return? What does the hello query return? Oh, rich text ID. Okay, we want that. Is ID 1? No, ID isn't string 1. It's a number. So, I mean, maybe I'm over enthusiastic, but I feel like it's hard to overstate how insanely impactful this is to an entire team's developer productivity and sanity. Okay, so now we have this auto-generated Apollo client wrapper. What I have is this this React app that's running here on, I believe it's localhost 3001. Okay, so the very first thing that we could do is just kind of confirm that everything is working. And so this might be useful if you aren't intimately familiar with maybe how GraphQL works, but the way that it works is that it's basically just a regular HTTP request that has a specifically formatted body. And so we'll just take a query. We'll just take like user ID and email. And then what we'll do is we can actually use this code exporter button and grab this fetch here. And we'll just put this at the top and like cut some out of it because it'll be a little bit long. So what we're gonna do is we'll call this request. The GraphQL URL is gonna go in here. The query is going to be this. The variables are just going to be empty. We don't need those for this. And we also don't need an operation name. The other thing that we probably want to do is in headers, we probably want to put content type as application /JSON. And we also never do this, but we're going to put Hasura admin secret before we do the actual authentication, just so that we can check that everything is working. and my super stellar secret is, my secret. So that'll allow us to kind of bypass stuff. So we have that. Then the result is going to be awaiting the request.json. And then we say console.log, got data from GraphQL with result. And we'll get rid of all this nonsense. And yeah, that's basically how you make a bare minimum GraphQL request. Is it's just a JSON object that gets posted, and it has a query. It has a variables object. If your query takes variables like, ID int, then we would need to come down here and say variables, ID1 or something like that. And you can optionally pass an operation name to identify it. But you'll save that. We'll come here. We'll pull open the console and save it. And we will call this test function. And we'll catch the error and just console log it. Okay, not a valid GraphQL query. Okay, let's see what we sent. Oh, yeah. Whoops. All right, sweet. And then now we actually have data. So we can see our true users, and everything is working the way we need it to. All right, so the last thing that we're going to do is we're going to implement Auth here. And so the way that Auth works, I'll just very briefly kind of glaze over this, is that Hasura has two modes, Jwt and Webhook. Jwt is better. I'll just simplify it a lot. Jwt is better because it doesn't have to hit your Auth server on every request. So you aren't going to get dinged with a lot of like round trip latency. You only auth people with Jwt once, and then again for refresh tokens. And so the way the Jwt works is that you have to tell Hasura, hey, Hasura, this is what type of Jwt secret I have. So we have an HS256 signing key. And then you need to give it a key, which if you're using RS512, you can't do it inline like this. And your key should not be this. But yeah, so the two things that you need to turn on to enable authorization or authentication in Hasura is just these two things. One is a way for it to verify what a valid JWT token is and is not. And the other is a default role for everyone who has not authenticated. So by default, everybody is going to be anonymous unless you're passing the admin secret and telling Hasura, hey, I'm the admin, I'm the owner. Or unless you're passing an auth header with a valid JWT that's been signed and it can verify it. And that is what you see here in this authorization header with a bare EY. We'll look at that in a second. And so what authentication looks like in Hasura, we'll do this super quick. We have to create a JWT auth server, but I'm just going to steal one that I've written before. You really only need like one endpoint, which is that you need something that can sign a token with a secret. It's not super complex, so what I'll do is I'll just make a single index.ts here. I'll put that stuff in there. We'll just actually make this JS, put that stuff in here. We'll get rid of all the types. And this, we're not going to do this because this is awful. And then this key needs to match what we have here, which in this case is this. And so what we do is we're going to replace this just with a static key. Generate JWT, get rid of the types, get rid of the response type. And here's the only thing else that you need is that you need to tell Hasura what is the default role that it uses in permissions when this user logs in, and what are the roles that the user is allowed to ask to be instead. And this is allowed roles is mostly useful for things like impersonation. So if you're a manager and you want to view a dashboard as if you were an employee, then you would have something like this. You'd have a manager and employee as your allowed roles, and your default role would be manager. And then to view a dashboard as an employee, you would send Hasura role in the header to the request, and that one particular request would use your employee role, or however many requests you wanted to use. But that's the gist. And then outside of those, you can sign whatever custom claims you want as long as they start with Hasura. Like we mentioned, usually people put a user's ID in there. They do have to be strings. So yeah, this whole thing is basically how to do JWT auth. And then, of course, the only thing else that we need is a web server that can return it. And so what we're going to do is we're just going to do this. We're just going to do express and make single endpoint super bad. Okay, so yeah. And we will say const express equals required express. What's that? Users. Okay, sweet. And then we will just say app.get slash jwt auth res const user ID equals rec.params dot user ID, and then we will do const token equals generate JWT, which has an ID, and we will do res.json token. Okay. Yeah, this should basically be the world's worst auth server for Hasura. So just to confirm, then what we'll do is we'll do node index.js. Oh, and I need to do an app.listen. Let's do like 5,000. Okay, not broken. Sweet. So that means it should be running on port 5000. Cannot get index, which is true. but can you get GW auth question mark user ID 1? ID is not defined. Oh, dir. Okay, this is just going to take an ID then. You know what? We're just going to hard code it. It's fine. Okay, sweet. So now we have this. Copy paste this into jwt.io. Take encoded. And yeah, so now we have this JWT, which is encoded with these claims. And if we take this token and we put that inside of our dashboard here, so we put this as bearer and then this token, you should see this little decode JWT inspector guy pop up. And if you click inspect, then you can confirm that the validity is right. And you can look at the payload. And you might ask, okay, great, but what's the point of this? When you can just put it into jwt.io or some other inspector service. And the point is this. If I change this key to that instead of this, so the key is wrong, and I run this again and generate a new key, then we put it here, and we can see that this is still technically a valid token, but if we put it in Hasura, this will not, well, I just gave it away. It will not verify. And so like really all that Hasura is doing here, though it is very helpful, is telling you whether or not a specific token is going to work on your Hasura instance when someone passes it in their auth headers to log in. We can do the same thing here if we just copy paste this, and jwt.io will tell us I don't know why it's saying that the signature verified. But yeah, anyways, the point is that the reason why we have that feature is so that you can quickly and easily confirm that your tokens work. Okay, so wrapping it up, this is what we're going to do. Now that we have an auth token, which I think is this one, this is the valid one. Okay, sweet. So now that we have this valid auth token, what we're going to do is we're going to make this fetch request in the React app. And the data that we'll get back will be only data for that user. And so all we have to do is rip out the Hasura admin secret here. And instead we put authorization. Well, I guess I copy pasted it. All right, sweet. And so we query for all users our token claims are signed, that we are the user role and our user ID is 1, which means that we should only be able to see the first user record. And so if we come back to this app, we clear it. I got to move this chat thing out of the way again. And we look at this, then bam. Now we can only see the user that we are authenticated as. We could see it here. So yeah, pretty cool. And just to prove it, then what I'm going to do is I'm going to rip out the whole auth header, let that reload. And now what we have in this response is that the field user isn't found in our query root. And you can see that error is down here because it's true. We are now an anonymous user, and anonymous users can't even see the user query type in the schema when they introspect. So yeah, maybe if you folks are interested, I can do the integration with the Apollo client really quick, since we have the SDK already generated, and I can show how to wrap the app root in it and query and like render data with it. We have about 20 more minutes. I don't know how many folks we still have. Oh, we still have 7 folks. If that would be interesting, I can definitely do that. But yeah, that kind of covered a lot of ground. So yeah, I can either show how to pull in Apollo client really quick and wire it up to our auto-generated kind of type safe GraphQL query client and like use that data to render in the React app and interact with the Strapi and GraphQL stuff, or I can, we could maybe just do random questions. Yeah, can you show the process? Yeah, absolutely. Yeah, I'll just do whatever you guys want to see. That point is hopefully to make it interesting. So, okay, so yeah, this is the last. Yeah, definitely. That was a long webinar. So it's cool that people are still watching, and I hope that there is some useful stuff. But yeah, so the last bit that we need to do to kind of pull in this, let me close this here. So we have this generated GraphQL client. This is already there. And the other thing that we have is we have the I think I deleted for some reason it deleted the wrapper hooks. It's okay, I can go grab those again in a second. But yeah, kind of the last thing that we have to do to use those is just pull in Apollo. So the first thing that you have to do is you have to set it up and wrap it in your app root. So let me see what the layout is here. We have main. The Apollo, you always want to put things like stores, so like context providers, stores, Apollo wrappers, anything that like wraps the top level. You generally want to put them in main and not app, because the app is kind of like business logic still, but here you can tell that it's just bootstrapping the bare level kind of like infrastructure and backbone for your app. And so what we have to do is we have to grab the we got to grab the Apollo client React docs, because I still can't do this from memory. And then, yeah, we already have those. In-memory cache, sweet. New Apollo client. All right, this is the bit that we need. So client, the URL, this is going to be localhost. So this is going to be the GraphQL server URL. You can find that here. And then the cache doesn't matter. It matters if you're, it matters in like larger, super big applications, or if you have super like resource or performance intensive use cases, but in general, an in-memory cache, especially for small stuff like this, is fine. So you set up the client, and then you need to take the provider, which is here, and pull in the provider, and then we'll go wrap it under that, and we'll put the Apollo provider here, and we'll put our app underneath it, and the Apollo provider needs the client. You can see it here, and the props, the client, and what goes in the client is the client. So if we save that and we come back in here, then we can double check that this is still working. Okay, sweet. And what we'll do is we'll grab the grab this browser extension just to make sure that this is, if they have one, because I feel like it'll tell you if your store is actually integrated. Okay, install the extension in Chrome. Okay, maybe this is it. Sure. And then what we need to do is put connect to DevTools true to the Apollo client constructor in our app, which, okay, sweet. So let's go ahead and do that. Close that, and reload. And I'm gonna have to close and open this again. And Apollo. Okay, sweet. Got data from GraphQL. Okay. Well, it does look like it's loaded, which is good. And then now we just have to actually make some queries. And so what I'm going to do is I'm going to steal this. I'm going to steal these hooks and put them in over here. As Apollo client hooks. Okay, and then I should be able to come in my app. And use type query. And then let's do this. Use type query, something from Strapi's. ID true. Rich text field true. Date field true. And then we got to destructure this typically. So this will be data loading error. And then you typically, this is the typical idiom. So you have like if loading, you would make a nicer loading component than this, but you basically be like return loading, and then you'd say like if error, return error, and then you typically want to like stringify the error message. Error dot message. And then if we hit below these and we haven't returned, you don't need another if case because these are guard statements. And so we know that at this point, it's neither loading nor errored. And so we can only have data here. So let's get rid of this. Let's get rid of this. And then at that point, what we can do is we can definitely just get rid of like all this. And we can say like data that's something dot map it. And then we can return like p it dot ID. I will make this it dot date field, it dot rich text field. Okay, super ugly. But I mean, yeah, it's really nice to be able to have something like this and just know that like these are all the fields on it. It's dynamically generated. You can hover over this Lambda parameter and you can see all the types. You get autocomplete. It's super stellar. And so then what happens? And then ta-da. So now you can see that we have ID 1 with date field 2021-0406, not very rich. And you can see in our Apollo queries too, that we've made this something from Strapis. And again, and yeah, so let me actually make this like a little bit easier to see, and let me add some so that it's we don't need this logo, we don't need that. Okay, also one thing I want to note really quick, if you haven't used this to build apps, whether you write Vue, whether you write React, Preact, whatever, this development server that uses ESBuild is incredible. It's insanely fast. You make a change and in like 2 seconds, it's propagated. So if I change this here, like hello, and I move this out of the way, and I click save, it's instant. Save, instant. I think it's pronounced Vite or Vite. It's super nice. I use it for both Vue and React. Highly recommend it. Okay, so now we're pulling in this data from our use typed query hook in Apollo. This is what we have up here in this API. This is GraphQL Zeus that we wrapped. These are our conditions. So the first set is arguments, and the second object is selection sets. So let's put a little bit more data in here so we have some more stuff. So what is this? Something from Strapi's. Let's clone the row. Created by, updated by, rich text field. This will be super rich. Date field, this would be 2077. I don't know if these values will allow me to save it. Okay, so we have that, and then let's clone it again. So just absurd. Okay, so now we have 3 rows. If I come back to, let me close all of these. If I come back to this, then boom, there's all 3 of our records from the database. And so, yeah, there's the ID. I could maybe make this a little bit easier if I put ID, date, rich text. This UL, li. This will be a fragment slash UL. Okay. All right. Yeah, that really just doesn't look good. Okay, there you go. Yeah, so now you can kind of see that we have those 3 records. And then if we want to filter, we can do that in a type safe way. So I press Control Space, I get all of the possible options. So distinct, limit, offset, order by where. Okay, so we can say where. Then what do we want? Okay, so we can say where date field is greater than, this will need a UTC date, so I don't actually want to do the date field, but maybe I can do it with a string. So after the date 3000/01/01, there's not a good chance that that will work. Yeah, there you go. So we just filtered every record where the date comes after the year 3000 and January 1st. And I think you can also do this. It's fairly flexible. So if you wanted to do the more common version, so like let's say this, I think the like European way of doing it is the month, the date, and the year. So if this was like or the yeah, month, day, then year. So if this was like wait, no, day, month, year. So this was like 25th of February 3000. That should also work. Oh no, it doesn't. Yeah. Okay. But yeah, so there we have it. And if you look at data, you can see that it is strongly typed here. So it'll show you what all that is. And if we data, we press here, then yeah, we get all that information. So this is basically all you have to do to integrate Apollo. So pull it into your main, pull in, let me separate these. I think I auto sorted them. Pull in the Apollo client and some caching strategy, pull in the provider, create a client and give it the URI to your GraphQL server and give it the cache. If you want it integrated with the Apollo Dev Tools, pass true here. And then just wrap your app with the Apollo provider. And then you'll have access through all the query hooks, like use query and etc. From inside any component because they're scoped to that context. And yeah, let me make this terminal smaller. But yeah, basically like it all fits on the screen. So there you go. Mhm. Um, okay. We have like 30 minutes, I think. Um, can I be useful to anybody? Talk about whatever, answer questions about like just general web dev, GraphQL, uh, like TypeScript, React, Vue, Node, anything. Definitely have an open discussion. Um, but yeah, I mean, that pretty much covers the bulk of the material that I had for today. I do. Uh, I really love it. Um, I think also a lot of people have the misconception that it you can only use it for Vue because it kind of started off that way where the React and the Preact templates and support were like a best effort basis. But yeah, after the 2.0 release, it kind of shifted into being more of like like a snowpack kind of thing, where it's just meant to be a really rapid um, bundler and development platform. I mean, I'm sure you might be aware it's built on top of that ES build tool in Go that guy Evan Wallace has built, which is just fantastic. So it's they have templates for like Svelte, for React, for Vue, both Preact to TypeScript, non-TypeScript. So um, the dev experience is super great to just press save and then have your content hot reloaded in like less than 50 milliseconds. It's just a really solid like workflow, I think. um, I don't I don't know if you folks have ever used Code Sandbox, that the site that I was demoing on for a little bit there. So Ives, the creator of it, he's innovated in a lot of ways. But one of the really impactful talks that he gave, I can't remember if it was like a React conference or what, but it was some global dev conference. But Ives was really focused on improving bundler semantics. And he had this idea of like 50 milliseconds is the is like the cutoff for what a bundler needs to be able to like perform in for your development cycle and for everything just to feel fluid. I can't remember the name of the talk, but he goes pretty deep into basically how bundling and things like Webpack and Parcel work, and kind of like what leads to them being inefficient, and what sort of advancements could make them faster. It was mostly about bundling and hot module reloading. Super interesting. Uh, super interesting. Um, yeah, I would say that that's a good way to put it. Um, it it sort of tries to take the role, like if you'll let it, as kind of being like a data aggregator platform. And what I mean by that is like it's not always so much a problem for greenfield projects or startups, but um, when you need to integrate either a lot of platforms that you own or external like vendor APIs and services, it can be really difficult because you have basically all these different lines of communication. Um, and it's difficult both from a technical sense and then also from a social sense because being aware of kind of like what lives where and what does what and keeping track of it all is difficult. And so the idea of Hasura is basically at the core, it's take either an existing data source or use the web GUI to build up your own and expose that over GraphQL. But where it really shines and kind of excels, I think, is when you use it to as sort of like a central gateway because it allows you to join data across services. So it's similar to the concept of schema stitching or like Apollo's vendor-specific federation spec. But instead of being only for databases or only for APIs, it allows you to join data across a combination of APIs, both GraphQL and REST, and databases. And databases not only in the sense of like a a homogeneous database, like we've got a bunch of Postgres or we've got a bunch of MySQL, but we have a feature called Generalized Joins, which is allowing you to join data that live in different databases, which is something that you see. And I think big data calls them like data lakes or data hubs. So it's like Presto or like Snowflake or something like that. Though it's not necessarily so much as like from like an analytical standpoint as a data access, right? So yeah, I mean the idea of Hasura is basically that like you have data, it might live in a lot of disparate places, and you want a way to provision and provide access to that, and also to kind of have a sane way to manage things like permissions. It needs to be able to integrate with your existing like auth system if you have one. So we really had to build it in a way that was entirely, no opinions, agnostic as to how your stuff might be architected. Because when you when you try to bake a lot of that functionality in, which Hasura did as a previous iteration of its product, you wind up sort of boxing yourself in and not being flexible enough to address a lot of the niche use cases. And so the thing that happens is it becomes useless if it can't if you can't basically bend it to do what you want, if it's not a cookie cutter out of the box thing, right? And so, yeah, that's kind of the general idea of Hasura. And then as an add-on, you have things like event triggers, which Strapi also does this. It's just webhooks that are like called as a response to changes in your database. So it's a reactive thing. But something like that, you would have had to spin up like a job queue system like Bull or in Redis. But yeah, also cron jobs, which again, Strapi does too. But yeah, that's pretty much the gist of it. So it's useful if you're building a monolith, I think, because it's nice to, like, no matter who you are, it's always nice to have some kind of app that lets you click buttons and, build databases and then expose them through APIs. It's also super useful if you have a bunch of microservices or need to be like a systems integrator. But yeah, kind of a long-winded response, but yeah, that's the gist. All right. I think that pretty much covers everything that I had for today. I hope that there weren't any questions left. But yeah, I think I'm going to go ahead and sign off for the evening. So for anybody who's still in the audience, if there's anybody in the audience, thank you for attending. And I hope that you found it enjoyable and hopefully useful. And yeah, thank you. Thank you for having me. All right, bye everybody.